This video shows you some of the things that can go wrong when you use data that are not of very high acoustic quality, and this is unfortunately true of a lot of material where we're working with conversation. The material I'm going to show you is especially difficult to work with because it's recorded from the telephone and there's quite a strong background buzz. And there's two speakers speaking sometimes in overlap, so it's a file which is absolutely full of difficult things to deal with. You need to understand why some of these things are a problem, and you also need to realize that there are things that you can sometimes do, and also sometimes you need to know that there is nothing that you can do to fix what you're hearing. So here's the file that we're going to listen to, and I'll just play the first bit of it so you can hear how awful it is.
Oh, hello. Sorry to hear about your bother.
Oh, that's right. I've got the police here at the moment.
Oh, have you? Oh, I won't keep you then. Anyway, so Elizabeth's coming home. You're going to see me on Monday then?
You should be home Monday night.
Lovely.
Okay, you can hear that there's a very strong background buzz, and when we make a pitch file of this background buzz turns up as an additional kind of F0 trace, because PRAAT doesn't know the difference between what's speech and what isn't speech. So if we take this little sample from the very beginning.
Oh, hello. Oh, hello.
And see what PRAAT has done with this in the pitch trace, you see where we go. So you can see that the first thing that it's done is to pick up the background buzz and tell you what its F0 is, which is what PRAAT is designed to do. You don't want that, and if you are going to make a nice drawing of the kind that we saw earlier, then you really want to get rid of this kind of noise, and PRAAT lets you edit these pitch files quite easily actually. So if you select the thing that you don't want, it's possible to do things with it. Like you can unvoice it, and unvoicing it is one way of telling PRAAT to assume that there's no pitch, because it can only find pitch if it assumes that there's voicing. Essentially, where PRAAT finds periodicity in the waveform, it assumes that it's voiced because PRAAT's there to determine whether it assumes that it's working with speech. So let's unvoice this, and you'll see that it just gets rid of the background buzz. Now let's go to the oh hello part, and you can see that that's not worked out quite the way we would have liked, but it's better than what we've got on this pitch trace.
Oh, hello. Oh, hello.
Where it's not quite high enough, and it's therefore estimated an F0 value lower than it should get. Now notice that there's three, because I put an extra one there, pulses where PRAAT thinks that there's voicing when in fact it's that background buzz, and we do need to get rid of those, so let's get rid of them. Now the numbers that you can see here on the screen reflect what PRAAT thinks is the most likely place for the F0 to be. So for instance, at this point here, it thinks that the most likely value of F0 is where it's put it, at number 9. 9 means very likely, and that's 372 Hertz. But you can see that PRAAT also thinks that there could be F0 here, or here, or here, or here, or here. But you can also see that these numbers are lower, right? You can see these are numbers like 3, or 4, or 7, or 6. The highest number is 9. So where it's got the highest number, that's where it's estimating F0 to be. Now this part looks pretty good actually, and if you listen to it, it's a very good match to that, so we can leave that alone. But here, that's not right, and if we listen to the original file, you can hear that that's just kind of echoey noise on the telephone line. So this is something that we really need to devoice or unvoice as well, so that we'll end up with just this. Now let's just go back here, and I think there's a part where I think Leslie is still talking there, and then here I think we have also got some F0 in you can hear that. You can also see it on the spectrogram. These horizontal bands are indications of the harmonics, but on the pitch trace, oh yeah, they are showing up, but there's that last one just there, and I think we could improve this by 1 glottal pulse just by hitting on it there. So we've ended up with quite a good, accurate pitch trace there, despite the rather lousy quality of the recording. Let's see if we can find some other places where PRAAT has not done such a good job. I think here is one. You can hear that at the beginning here, for example, Leslie's pitch is quite high, but it's also quite creaky voice quality. And PRAAT is struggling with that here. That's the wrong pitch. You can also see that PRAAT has made some estimates higher up. And one thing that we can do is to reassign the location of these pitch pulses. And you can do some of this instantly by moving things up either by a fifth or by an octave. These are musical intervals. An octave doubles the frequency. So all of those spots go up. Let's listen to that. That's a much better match. That's a much better match than the original one. Any kind of pitch tracker will make these sorts of errors, and they're caused by wrongly estimating what the F0 will be. They often estimate by multiples of 2, so they either get it wrong by half or they get it wrong by doubling. So this is one reason why you have to go back and check auditorily and visually to see whether you can improve it. Now, we've got these funny little pitch traces here. These are down there, and on the audio we haven't really got any voicing, and if you look at the interval there, I don't think anybody's saying anything. So I think on this bit here we want to unvoice it. And then off we go into another little stretch. Now again you see we've got very high pitch at the beginning, but here you can hear and you can see this creaky voice quality. You see these vertical striations, these represent creaky voice quality. And PRAAT will always struggle to find F0 around those things. It's very, very difficult. So I wouldn't bother estimating where the F0 is. It's somewhere down here in that lower area. So the next low-pitched thing that looks incongruous is there, and that corresponds to this, which again is a place where nobody's speaking, so I think we can safely unvoice this. And we've got this now in this window, and if we listen to the audio file, that's pretty good actually. We've now cleaned that up and solved some of the errors that there were in the F0 tracking. You can see there's quite a lot of these errors. This part here is fine. This part looks, again, I bet this is going to be a place where there's actually silence or no speech, no voicing in the speech file. Indeed it is, so we can just get rid of it, we can unvoice it. And then probably this part is as well, but let's see. No, here we've got lower pitch. This still isn't right, so we could probably try shifting that an octave up. That's better. That's a better match for where it should be. That just leaves us now with these funny values, which are very high. And they are there. So these ones are now an octave too high, and we need to bring them an octave down. I've got one little bit wrong there. And that leaves us then with these two funny pulses here. let's see if we can hear those. I think that's a bit of, it's where there's no voicing in the speech, so we'll unvoice that. So I think we've cleaned that part up. There we go. So these are some of the very common kinds of problems that you encounter when you work with non-ideal, non-lab data. Even in lab data, actually, PRAAT will make mistakes, but particularly when we're working with real data, we have to go through and manually correct a lot of F0 traces. So the main things to remember are that PRAAT will often put a pitch trace where there is no F0 if there's a background buzz or something that's periodic somewhere in the background. And secondly, PRAAT will often make errors, usually octave errors, either by doubling or by halving its estimate of the value, simply because it just makes mistakes. So you need to go through and make sure that those things are cleaned up before you do anything, for example, like working out what a speaker's highest and lowest or average F0 values are.